Hello for all Form 3 students. This will be the first video during the class suspension period. I will upload more, but this one, because of the animation, I need some more time for the editing. For Form 3A and 3C students, I have already covered this part, but you can still watch this video as a revision, as a recap for what we have discussed before the class suspension or the Chinese New Year holiday. For 3B and 3 students, this video is actually for you all because we haven't had the discussion on this part about fractional distillation of crude oil. Let's have a recap for what we have discussed, what we have done before the holiday or the class suspension. I use a sample of the Coca-Cola. It is a mixture of many things such as sugar, colorings, and water, etc. I try to separate the water from the Coca-Cola. Now use this setup. You should learn this setup in Form 1 Integrated Science in the purification of water. Now, what are the principles of these separation method? Now, first of all, we have many things inside the Coke. However, only one component, water, it has a much lower boiling point than other substances. It is only having the boiling point of 100 degrees Celsius. However, for other substances such as sugar, caffeine, they have much larger melting point and boiling point. So if we heat the mixture, when it reaches 100 degrees Celsius, the water will start to boil, but other things still remain inside the mixture. When the water boils, they will turn into gas form. This is steam. They will enter the delivery tube, go to this test tube, being cooled down in this area, and being condensed to give you back water. So in Form 1, you learn this method for water purification to get clean water for drinking. Now this is also a method for separation of some substances from a mixture. We'll discuss it in the end of the term. Another thing we have discussed before the holiday is about crude oil. Now, although that we say that crude oil it is a fossil fuel, it's a fuel we can burn it to release energy. However, no one will burn crude oil directly. The reason is if you burn the crude oil, there will be a lot of harmful gas. Remember that I have shown you this video. If we burn the crude oil, they will give you a lot of black smoke. Of course, you know that they are air pollutants. And we say that in chemistry, it burns with sooty flame. And also, there are many useful substances that we cannot generate them within the laboratory or in a short period of time. They are from the dead remains of ancient animals and plants. They are the treasure from our ancestors. So a lot of useful substances, it will be burned to release energy instead of used to produce useful substances such as plastics, such as some other materials. So if we burn crude oil directly, I will give one word to describe it: waste. It is definitely a waste. We'll waste the crude oil. So our question will be how to make crude oil useful. Instead, we will have some more separation technique. We use a technique similar to distillation. Now, this is a diagram for a technique we're going to discuss in this video. The setup will be similar to the distillation. We just replace it with the crude oil, or we say petroleum. To make things smooth, actually we'll use some mineral wools, it is some substance like cotton to soak the petroleum inside. To make things simpler, I'm going to remove the labels here, and I'll just focus on the test tube and give you a simple case to illustrate what's going to happen. Now magnify this part, and I assume that the crude oil, there are only 1, 2, 3, 4, 5, 6, 7, 8 different molecules. They're hydrocarbons, compound of carbon and hydrogens. Of course, in the real case, the crude oil, they will have around hundreds of hydrocarbons inside. To make things simpler, I just assume that there are 1, 2, 3, 4, 5, 6, 7, 8 components, 8 molecules inside. I give you a table here. The table, they are the boiling points in ascending order for these hydrocarbons. Now, I'm going to heat this tube. I'm going to heat this tube. If I heat this tube, the temperature will increase, and I want you to think about what will happen if the temperature of this mixture increase gradually. Now I assume that the room temperature here in this room will be 25 degrees Celsius. So if we heat the mixture here, the temperature will increase gradually. It will increase to 30, 40, 50, 60, 100, 200, and so on. So if the temperature now increase to 40, it is going to increase to 40 degrees Celsius. What will happen? Now see from the table, one of the hydrocarbon will have something. This one, hydrocarbon, C5H12, it has a boiling point of 36 degrees Celsius. So we heat the mixture from 25 degrees to 40 degrees Celsius. Of course, it will reach 30 degrees Celsius, and then 31, 32, 33, 34, 35, 36. When it reaches 36 degrees Celsius, it reaches the boiling point of the C5H12, this substance. It will boil and leave the mixture. Eventually, it will have nowhere to go, but the only exit will be this delivery tube. So this one eventually will go to this tube and leave the mixture here. Now how about these 7 components? Why they're still here? Why they're still here? The reason is very simple. They have the boiling point larger than the current temperature. Now the temperature of this mixture is 40 degrees Celsius. All the boiling points of these hydrocarbons, they have the boiling point greater than 40 degrees Celsius. They are not boiled in this case. So one of them is being boiled, is removed from the mixture. Now I eliminate it from the table. Now the heating continue. These things still here. So if we heat this up from 40 degrees Celsius, eventually to 70 degrees Celsius. Now, of course, temperature will go to 40, from 40 to 41, 42, 43, 44, 46, 36, 7, and so on, and 49. One of the hydrocarbon, this one C5H10, will go to boil. And also, if the temperature continue to increase from 50, 51, 52 to 60, 61, 62, 65, 66, 67, 68, 69, 68. This one will also boil. It reaches a temperature here, the boiling temperature here. So before reaching 7 degrees Celsius, one of them will boil at 49 degrees Celsius. Another one will boil when we reach 68 degrees Celsius. They will leave the delivery tube eventually because they're gas. They have nowhere to go. They only have one exit here. They will leave the test tube. So these two, C5H10 and C6H14, they leave the mixture here. So I'm going to eliminate them also from this table. Now the mixture, we only have 5 substances here. Now we're going to continue the steps. The pattern will be similar to, I'm going to speed this up and you know what will happen. If we continue the heating from 70 degrees to 100 degrees Celsius, when it reaches 80 degrees Celsius, one of them, C6H12, it will leave the test tube because it's going to boil. I'm going to eliminate this again. We continue the heating from 100 degrees Celsius to 200 degrees Celsius. It will reach 126 degrees Celsius first, and then 174 degrees Celsius. In this range of temperature, CHH and C10H32, they will leave from the mixture. They also got eliminated, and so on. The next one, if we increase the temperature from 200 to 300, this one, C15H32, boil and eliminated, and so on, and so on. Back to our first picture. Now, we're going to do this in the distillation setup. If we just heat it, you know that all of the components will leave the mixture one by one because they will reach a boiling point, they become the gas, and go to the test tube. However, if we just heat the mixture and leave it there, actually we did nothing. It is meaningless. We just transfer the substance from the boiling tube to another test tube. Just like this. The animation was just like this. If we just leave this apparatus alone, just do the heating without anything else, they will just go into the new test tube one by one when they reach their own boiling point. Completely meaningless. However, if we do one little step, things will be very different. Now, what if we have the test tube here to collect the things being boiled and condensed? What if we replace the test tube regularly? Now, I'm going to do the following trick. To make the things clearer, I'm going to remove some of the labels and diagrams here. I just leave the test tube here for a better picture. Now, I'm doing the heating again, from room temperature to 36 degrees Celsius. So from the first case, we know that this one, C5H12, is going to boil and go to this test tube. It boils, it becomes a gas, go to delivery tube, and go to this test tube eventually. We continue the heating until the temperature is a record by the thermometer and when it reaches 40 degrees Celsius. When we look at the thermometer, when the temperature reaches 40 degrees Celsius, now we do one simple trick. Very simple trick. We remove this test tube with the things collected here. We label this test tube as test tube number 1. Now, what are the things inside test tube number 1? They will have the molecules being collected with the boiling point below 40 degrees Celsius. What does it mean? We heat the mixture. All the things with boiling point below 40 degrees Celsius, they will boil and condense in test tube number 1. When the temperature reaches 40 degrees Celsius, we remove test tube number 1. Label it. So C5H12 is going to be, it is already eliminated from a mixture. It is already here. So I eliminate from this table, and we know that they are actually being collected in test tube number 1. Now put the test tube number 1 to another part, stop it, and then put it in another part of the laboratory. Sorry, I should have this animation clearer. I use a new test tube and I continue the heating. So if I continue the heating, the temperature will increase from 40 degrees Celsius. It goes up. First station where it reached 49 degrees Celsius. This one will go into boil. C5H10, this is your turn, you're going to boil. It's 49 degrees Celsius. So it boils, it leaves a mixture, it goes to the delivery tube being collected in this test tube. I might exclaim because it's already vaporized and being collected. I continue the heating. The temperature now increased from 49 degrees to 68 degrees Celsius. Another one, this is your turn, C6H14. It has a boiling point of 68 degrees Celsius. It's your turn to boil. It boil and go to another test tube here. I should say the same test tube as before. New test tube. So continue the heating. When the thermometer here, it tells me the reading 70 degrees Celsius. Okay, fine. I'm going to do this trick again. I remove this test tube. Now this test tube, I mark it as test tube number 2. This test tube is containing the molecules, the substances that's having the boiling point with this range. The reason is I put the test tube here when temperature at 40 degrees Celsius. I remove it when temperature reach 70 degrees Celsius. So all the things being collected, they must have the boiling point between 40 to 70 degrees Celsius, just like these two, C5 and C6, these two molecules. This two is being collected at test tube number 2. So I put it aside and they are eliminated from the mixture here. I do the trick again. I use another new test tube and I continue the heating. Now I think that you will know the pattern, so I'm going to speed this up. When temperature goes to from 70 to 80 degrees Celsius, your turn is your boiling point. You're going to boil and being collected. I continue the heating. When temperature goes to 100 degrees Celsius, I remove this test tube, mark it as number 3. They will collect all the molecules being boiled in this temperature range, 70 to 100 degrees Celsius. Put it to another part of the laboratory. Again, I'm going to replace it with another new test tube. The things continue again, and again. So temperature increase from 100 to 126. You boil. Another one, when the temperature reaches 174 degrees Celsius, your turn to boil. When the temperature reaches 200 degrees Celsius, I remove this test tube, mark it as number 4. These two I mark as brown in color in the table. They're eliminated from the mixture. Put it aside and I'm going to replace it with a test tube, so on and so on. Now, this is actually the term for summary. What have we done? You may pause this video and think about what have we done before and go to this timeline again. I want you to think about what have we done before I move on. Okay, so please pause the video and think what have we done. So now I'm going to make a summary here. First thing, actually we're heating the crude oil gradually. So temperature increased gradually from 25 to 40 to 70, 100, 200, and so on. The hydrocarbons with lower boiling point, of course, they'll boil first because the temperature, they reach the boiling point of these substances first. These boiled hydrocarbons, they leave the mixture, enter to another test tube. The key is, at a certain temperature, I replace the test tube with another test tube. Now, so we have test tube number 1, 2, 3, 4. Now, we're going to return to these test tubes. These test tubes, I would say. Test tube number 1, they collect the things with boiling point below 40 degrees Celsius. Test tube number 2, 40 to 70. Number 3, 70 and 100. Test tube number 4, 100 to 200. Originally, we have the crude oil. Remember this circle, I put all the substances here. Originally, we have a lot of hydrocarbons here. There are 8 different hydrocarbon in this mixture. Now, it is a complicated mixture, but after I have done this kind of separation, they are actually separated into simpler mixture. Originally, the crude oil, they are 8 substances here. Now I separate them into 4 different parts. This test tube with only 1 substance here. This test tube with 2 substances here. This test tube with 1 substance. This test tube with 2 substances. I actually successfully separate them into 4 different kinds of test tube, and each test tube, they are less complicated. They are simpler mixture. They have the substances, the hydrocarbons, with their own boiling point range. So actually, each test tube, they contains the simpler mixture. We call them the fraction, just like mathematics. So in Cantonese, fraction in mathematics we call it 份數。好似每一個 test tube 係 crude oil 一部分。It just like a simple part of the crude oil of the mixture. In chemistry, in the accurate scientific term, they are called the fraction number 1, 2, 3, 4 instead of test tube number 3, 4. They are parts of the crude oil mixture. If we mix these fractions together, we'll get back the crude oil. But this time, now we separate them into simpler mixture. They are called fractions. Now we have a recap here. We separate the crude oil into fraction. And think about the setup. We're using a setup of distillation. So what we call this technique, yes, this is our title, this is a focus. This technique is called fractional distillation. All right. So now this will end the part 1 of the video. I will upload more later on. So in a later video, we'll compare some of the substances of each fraction and why we need to do this fractional distillation. How this setup, how this technique makes crude oil more useful. All right. So this ends today's video.